Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 9. We're continuing our investigation of trigonometry. Now, in the last video, we derived the unit circle. Very exciting. And from there, it only becomes more and more fun. Lots and lots of trig for everyone. Now, what we want to do is talk about tangent, secant, cosecant, cotangent. So just to review, we know that sine theta was equal to y over r, and cosine theta was equal to x over r. But on a unit circle, r is equal to 1, which means that sine theta is equal to y, and cosine theta was equal to x. Now, we defined tangent in a previous video to be tangent theta is equal to y over x. And if tangent is equal to y over x, then it immediately follows that tangent theta is going to equal sine theta over cosine theta. And right here we have a trig identity. And cotangent theta was equal to x over y, from which it immediately follows that cotangent theta is going to equal cosine theta over sine theta. There's another trig identity. And for secant theta, this was r over x, or 1 over x, and that tells us this is that secant theta is going to equal 1 over cosine theta. Or, if we want to think of it in a different way, if we take the reciprocal of both sides, another way we could think about it is that cosine theta is equal to 1 over secant theta. And in fact, while I'm thinking about it, these two imply, if you take the reciprocal of tangent and the sine over cosine, so 1 over tangent theta is going to equal cosine theta over sine theta. Well, cosine over sine is cotangent. So this is cotangent theta. So just to condense this, 1 over tangent theta is equal to cotangent theta. And we can go the other way. Tangent theta is going to equal 1 over cotangent theta. We have lots and lots of fun here. Let's box that. Let's box this. This is getting crazy. We got all these boxes. And we have cosecant theta. That's equal to r over y. Since r is 1, this is 1 over y. That tells you that cosecant theta is going to equal 1 over sine theta. And if we take the reciprocal both sides, sine theta is going to equal 1 over cosecant theta. So all of these facts here that I boxed are the reciprocal identities. So there we are. Very first thing we did is derive the reciprocal identities. These are the relationships between tangent, cotangent, secant, cosecant with respect to sine and cosine. So once you have sine and cosine, we can derive the other 4 trig functions, which is exciting. And it kind of makes sense because if you think about our triangles, they're ratios of sides of the right triangle, and we relate all 3 sides to just sine and cosine. So if we change those ratios around, they count for every possibility. They're all going to be based on the ratio of sine and cosine. That's exciting stuff. Now, with this information, we can do some more work with our unit circle. So for example, if I want to figure out what cotangent, we don't want theta. If we want to figure out what cotangent of pi over 4 is, well, this is the same thing as thinking of what is cosine of pi over 4 divided by sine of pi over 4. And cosine of pi over 4 is square root 2 over 2. Sine of pi over 4 is square root 2 over 2. Well, that's the same thing, so we get 1. Ta-da! If we want, say, tangent of 3 pi over 4, well, this is really the same thing as sine of 3 pi over 4 over cosine of 3 pi over 4, which is going to be square root 2 over 2 over negative square root 2 over 2. Alright, how do we know this? Well, we have a 4 in the denominator, so that tells us square root 2 over 2. 3 pi over 4 is in quadrant 2, which means the x has to be negative, so cosine's negative. And so we get negative 1. Ta-da! And secant of, how about 7 pi over 6? Pick something a little goofy. So this is the same thing as 1 over cosine of 7 pi over 6. So that's 1 over negative root 3 over 2, which is negative 2 over root 3. So this is just a reciprocal of the fraction. I just flipped this around. And now we need to rationalize the denominator. So we get negative 2 root 3 over 3. Alright. So that gives some examples of working through these. Lots of fun, as you can see. The key is just thinking of these functions in terms of sines and cosines, and then recalling where on the unit circle they are and what those values are, and then just working through those ratios correctly till we get something that looks nice. Let's see here. With that, I think we're gonna actually call that good for this video. I just wanted to work through some examples of this, and before I leave, I actually have 2 more things. We should first do a example with cosecant. How about cosecant of 5 pi over 3? So cosecant's 1 over sine of 5 pi over 3. And we are in quadrant 4, so that's going to be a negative value since y is negative quadrant 4. And so this is going to be 1 over negative root 3 over 2. So, well, okay, well, you know, we already did that work. So this is negative 2 root 3 over 3. Exciting. Alright. What about this question, though? And how about tangent of pi over 2? Well, this is the same thing as sine of pi over 2 over cosine of pi over 2. And that is going to be 1 divided by 0. There's my bad sound effect. 1 divided by 0. Keep in mind, this is not 0. In fact, if you say this is equal to heresy, this claim right here, it is heresy. Mathematical heresy. Let's make sure we stipulate mathematical heresy. So claiming that 1 divided by 0 is equal to 0 is mathematical heresy. We are going to box this in red. You do not commit mathematical heresy. You do not say that 1 divided by 0 is equal to 0. Instead, in this situation, since you cannot divide by 0, this tells us that tangent of pi over 2 is undefined. So whenever for these 4 trig functions here, sine, cosine, tangent, cotangent, secant, cosecant, since they either have an x or a y in the denominator, at some point x and y is going to equal 0. And when they do, you can't divide by 0. So these 4 trig functions, cotangent, tangent, secant, cosecant, we just say they're undefined whenever you get to situation 1 divided by 0. And then lastly but not least, a great way of keeping track of sine and cosine, secant, cosecant, because we know it's right here. We have secant is 1 over cosine, cosecant's 1 over sine. How do we keep track of that? Just remember Cosine is prefixed with a CO, so it's going to go with the secant because secant doesn't have the co in front, whereas cosecant already has a co in front, so it's going to go with the sine because sine doesn't have a co. Notice cosine, just secant. Cosecant, just sine. Sine, cosecant. Cosine, secant. So if you could just remember that little relationship just between the language, it serves as a mnemonic device. I feel like I just butchered that word. Alright. Alright. I give up. I could probably say Menodic. Alright. That's one for you guys to laugh over. Anyways, just keep in mind, cosine goes with secant, cosecant goes with sine, co, no co, co, no co. Okay. With that, we got our we got our reciprocal identities here. We have we looked at how to find these values, and we talked about what happens when you divide by 0. Don't do it. Alright, thank you for watching this video. If you've been enjoying our content, please consider subscribing to us on YouTube. We need your support. At the time of making this video, we are a far cry away from our 1,000 subscribers needed to be monetized. So I will appreciate any and all of you that do subscribe. I still appreciate you if you just watch the videos. Both types of support is highly appreciated by myself. And if you have been enjoying our content, I also would like to direct you towards our Patreon page, where you can give us financial support as well. Alright, thank you for watching, thank you for joining our math party, and I will see you next time.